this is about electrochemistry. හොඳට මතක තියාගන්න පුතේ. When it comes to electrochemistry, ඔයගොල්ලෝ මතක තියාගන්න ඕන reactions ಜಾති දෙකක් තියෙනවා. There are two types of reactions that you should record. The first one is the oxidation and the other one is the reduction. හැම වෙලේම oxidation කියන්නේ නිකන් නිවන් යනවා වගේ වැඩක්. Oxidation කියන්නේ අත්හැරීමක්. Oxidation කියන්නේ නිවන් යනවා වගේ වැඩක්. හරි එහෙම මතක තියාගන්න. එහෙනම් always in oxidation the removal of electrons will happen, and in reduction gaining of electrons will happen. මතක තියාගන්න පුතේ, always in electrochemistry the oxidation happens at the anode, right, and the reduction happens at the cathode. එහෙනම් බලගන්න. මෙතන පුතේ අපි ගත්තොත් always මේ වගේ සිටුේෂන් එකක් ගත්තොත් මේ සිංක් රොඩ් එක කොයි ඩයලෝඩ් H2SO4 තියෙන සිටුේෂන් එකක් ගත්තොත් මේකේ අපිට we can observe that gas bubbles will evolve near the sink rod, and also you can observe that sink strip will dissolve. Here, when selecting the anode, always the anode will be the higher reactive one, right? So the higher reactive will be zinc and an anode will be the zinc. But හැම වෙලේම always the oxidation happens at the anode. Oxidation කියන්නේ අත්හරිනවා, නිවන් යනවා වගේ වැඩක්. ඒ කියන්නේ removal of electrons. බලන්න. Zinc 2 plus වෙලා 2e වෙලා මෙන්න මෙහෙම first එක ගන්න පුළුවන්. Can we have a close look, right? We can have this, right? ඊට පස්සේ පුතේ මේකේ තියෙන H2SO4 ටික කැඩෙනවා 2H plus SO4 2 minus කියලා. මේ වගේ states අනිවාර්යෙන් මේ විදිහට දාන්න. When it comes to the cathodic reaction, it happens a reduction. Reduction means electrons තමන් දෙසට එකතු කර ගන්නවා, collecting electrons. එහෙනම් 2H plus 2e forms H2. මේ 1 2 එකතු වෙලා පුතේ zinc කියන එකයි 2H plus 2e zinc 2 plus 2e H2 කියන එක හදනවා. මේ electrons දෙකට මේ electrons දෙක කැපුණාට පස්සේ finally you can get as zinc plus H2SO forms zinc sulfate plus H2 කියන එක ගන්න පුළුවන්. ඊට පස්සේ අපි කතා කරනවා පුතේ තව example එකක් copper zinc උයි දාලා මේකෙත් dilute H2SO4 දානවා මෙහෙම solution එකක් විදිහට. මේකෙත් පුතේ when it comes to the anode වල oxidation එක වෙන්නේ. Oxidation means removal of electrons. එහෙනම් අත්හරිනවා oxidation කියන්නේ. එහෙනම් zinc කැඩෙනවා zinc 2 plus 2e කියලා. cathode එකේ වෙන්නේ පුතේ reduction එකක්. Reduction means තමන් දෙසට electrons ඇද ගන්නවා. එහෙනම් හැම වෙලේම මේ දෙකේම වගේ මේකෙත් වෙන්නේ H+ වලට electrons ගන්න එක. මේකෙත් වෙන්නේ H+ වලට electrons ගන්න එක. එහෙනම් 2H plus 2e forms H2. ඊට පස්සේ මේ දෙක එකතු කරලා අපිට ගන්න පුළුවන් පුතේ zinc plus 2H plus 2e forms zinc 2 plus 2e plus H2 කියන එක. මේ electrons එකට මේ electrons දෙක කපලා දාන්න පුළුවන්. එහෙනම් මේ වගේ we should basically remember two things. එකක් තමයි always the oxidation happens at the anode, always the reduction happens at the cathode. Oxidation කියන්නේ electron අත්හැරීම, reduction කියන්නේ electron එකක් තමන් දෙසට gain කර ගැනීම, right? ඒ වගේම මේකේ මතක තියාගන්න ඕනේ always when selecting the anode will be the higher reactive metal. So this is all about this. Next we are going to talk about electrolysis and also rusting of iron. We are talking about electrolysis. But the electrolysis means making changes to a chemical substance by passing electricity through a solution. ඒක තමයි electrolysis කියලා කියන්නේ. So for this we can use solutions like fused sodium chloride, like aqueous sodium hydroxide, like acidulated water. ඉතින් මේ වගේ use කරන solution එකට අපි කියනවා we call it as the electrolyte. Here in your syllabus for this time exam, they will only ask about electrolysis of aqueous copper sulfate, electrolysis of acidulated water, and electrolysis of fused sodium chloride. So the electrolysis වල මතක තියාගන්න හැම වෙලේම always the positive terminal will be the anode and the negative terminal will be the cathode. Positive terminal will be the anode and the negative terminal will be the cathode. So the anode එකේ තමයි oxidation වෙන්නේ. අන්න anode එක නිවන් ගිහිල්ලා. ඒ කියන්නේ oxidation කියන්නේ removal of electrons. එහෙනම් anode එකේ තමයි හැම වෙලේම oxidation වෙන්නේ. cathode එකේ හැම වෙලේම it gain electrons. reduction එකක් වෙන්නේ. එහෙනම් අපි බලමු anode එක. Electrolysis of aqueous copper sulfate. See the anode. Anode කියන්නේ positive terminal එක. So always negative ions are attracted towards it. එහෙනම් මේකේ හැම වෙලේම එන්නේ 4AOH minus හැදෙනවා O2 plus 2H2O plus 4E කියලා. පුතේ මතක තියාගන්න මේ anodic reaction එකයි acidulated water electrolysis කරද්දී එන anodic reaction එකයි එකමයි. ඒකත් 4OH minus කැඩෙනවා O2 plus 2H2O plus 4E කියලා. එහෙනම් මේ දෙකේම anode reactions දෙක එකම විදියයි. After that we are talking about the cathodic reaction. පුතේ cathode is the negative terminal. එහෙනම් cathode එක ගාව හැම වෙලේම තියෙන්නේ positive ions. When it comes to aqueous copper sulfate electrolysis පුතේ මතක තියාගන්න මේකෙදී මේ cathode එක negative terminal එකකින් හින්දා එයා ගාව තියෙන්නේ CO2 plus ඒවා. එහෙනම් CO2 plus 2E reduction එකක් වෙන electrons ගන්නවා. එහෙනම් forms copper කියන solid එක. මේ states දාන්න මතක තියාගන්න. හරි. එහෙනම් මේ දෙක carbon electrons මේ positive terminal එක mark කරලා තියෙනවා. මේ negative terminal එක mark කරලා තියෙනවා. Moving on to the acid diluted water part. මේකේ anode එක මේකේ anode එකේ වෙන reaction එකමයි. මේකේ cathode එක ගත්තාම පුතේ cathode is the negative terminal. It means එයා ගාව නිතරම තියෙන්නේ positive ions. එහෙනම් H2O acidulated H2O වල it has always H plus ions. එහෙනම් 2H plus cathode එකේ වෙන electrons gain කරනවා. එහෙනම් 2H plus 2E forms H2 gas එක. එහෙනම් this is about electrolysis of acidulated water. Next, finally, we are talking about electrolysis of fused sodium chloride. මේකේ වෙන්නේ පුතේ anode එක කියන්නේ it is always the positive terminal as always. එහෙනම් anode එක ගාව හැම වෙලේම තියෙන negative ions. That means මෙන්න මේකෙදි තියෙන negative ion එක තමයි Cl minus කියන එක. එහෙනම් 2Cl minus කියන එක පුතේ break වෙලා හදනවා Cl2 plus 2E කියලා. Right? ඊට පස්සේ when talking about the cathodic reaction, cathode is always the negative terminal. ඒ කියන්නේ එයා ගාව හැම වෙලේම තියෙන්නේ Na plus කියන එක කියනවා. මොකද fused sodium chloride ඉඳලා. එහෙනම් Na plus always cathode reduction එකක් වෙන්නේ. That means it gain electrons. එහෙනම් 2Na plus මෙතන Na plus එක electron එකක් අරගෙන it forms Na. sodium කියන එක extract වෙනවා මෙතනින්. Finally මේ දෙක එකතු කරලා අපිට මේ වගේ reaction එකක් ලියන්න පුළුවන්. එහෙනම් මෙතන electrolysis of fused sodium chloride වල sodium extract කරගන්න පුළුවන් solid එක. ඒ වගේම මෙතන අපි ගත්තොත් electrolysis of copper sulfate කියන එකේ aqueous copper sulfate කියන එකේ copper extract කරගන්න පුළුවන්. එහෙනම් this is all about electrolysis. Thank you.
So next we have to learn about what is corrosion in metals. But as a result of air reacting with metals, there can be changes in metals that is known as corrosion, and the changes that happen as a result of air reaction in ferrous or iron is known as rusting of iron, right? So now we are talking about electroplating. But applying a thin metallic layer on a given surface using electrolysis is known as electroplating. But when talking about electroplating, we have to remember these things, right? The object to be plated should be always used as the cathode, and a solution of salt of the metal can be used for plating, and the anode should be the plate or the rod made of the metal that is plated, right? For example, we are going to plate an iron spoon with copper, right? So here the cathode will be the iron spoon and the anode will be the copper plate. So this is, we call it as the cathodic protection, right? So here anode will be the positive terminal. Anode ek gawa puthe Cu break vela CO2 plus 2E වෙනවා. So that is kind of an oxidation reaction. අත්හරිනවා electrons. And cathode will be the negative terminal. Negative terminal එක ගාව හැම වෙලේම තියෙන්නේ positive ions. එහෙනම් CO2 plus 2E forms copper කියන solid එක හැදෙනවා. I think this is how electroplating happens, right? Next, we're going to test the factors affecting rusting. First of all, we're going to test how air affects rusting of iron. First of all the iron nails in the marker, they have a zinc coating. So to remove it, before each and every experiment of this, we are going to put the iron nails in an HCl solution for about 10 minutes to remove the zinc coating in the iron nails, right? So after that, we're going to take 2 test tubes and make the apertures like this, right? So here, when considering about A and B, you can come to a conclusion that the iron nail in A will only get rusted, but the B iron nail will not get rust. Because of why? Because of the coconut oil layer, the air didn't enter to the B test tube. On the same hand, because of the boiled water, the air which was inside the water was removed with the support of the boiled water. So since there was no air, rusting did not happen at B. So next we are going to test what component in air affects rusting. For this, we are going to set these apertures like this, and we are going to put inverted test tubes in this way. And here puthe in the test tube, one test tube is with iron wool. So you can observe that the test tube with iron wool, there can be a rise of water level, and you can observe that there will be 1/5 rise, right? So 1/5 of the test tube will be filled. So here you can come to a conclusion that oxygen in air is the component that is needed for rusting of iron. Because this, we can come to this conclusion because normally the 1/5 composition of air, 1 out of 5 composition of air is oxygen. So there was a water level rise of 1/5, right? 1/5 water level rise was there. So we can come to a conclusion that the component needed for rusting of iron is oxygen. Here we are going to test how acids affects the rusting of iron. So here we can observe that the rusting of B and C iron nails will be faster or will be quicker because there are 2 acids in B and C, right? Okay, next we are going to test how salts affect the rusting of iron. So here the rusting of B will be greater. The rusting of B iron nail will be greater because there is a salt. So when there is a salt, the rusting will increase. So in the third one, we can observe that rusting of the iron nail with ordinary cold water will be greater than that of the rusting of iron nail with a base. So this is the conclusion that you can rise. So here we are going to test the effect of other metals on iron, right? So for this we are going to use magnesium, zinc, copper and lead, right? To approximately 250 cubic centimeters of water, add a small amount of sodium chloride, phenolphthalein and potassium ferric cyanide, right? Boil the solution and add about 1 teaspoon of agar jelly to it and stir well. So this is a step that we have to do, right? And also place an iron nail into the first peri dish. Keep the strips of magnesium, zinc, copper and lead in good contact with the other 4 nails, right? So here, Pute, we can observe that since we are going to put phenolphthalein and potassium ferric cyanide to each of them, we can observe that phenolphthalein will turn to pink color in 2 and 3 parts because it had magnesium and zinc. There was no rusting and phenolphthalein turned to pink color. But when you consider the 4th and 5th ones, the potassium, the ferrous cyanide will convert to blue color because the rusting has happened, right? Because the iron was with copper and lead. So we can come to a conclusion when iron is mixed with more reactive ones, it will not rust, but iron mixed with less reactive ones, it will rust, right? So here we can go through the equations of this reaction. So here iron mixed with higher reactive ones, always the anodic reaction happens at the higher reactive metal. So magnesium, anodic reaction means it is an oxidation. So that means oxidation can be electrons magnesium Mg2 plus 2e venama, zinc 2 plus 2e venama. So that is when iron is with higher reactive ones. So here phenolphthalein will turn to pink, right? So after that, when ferrous, so iron is mixed with lesser reactive ones, the anode reaction will happen at the ferrous. So Fe2 plus 2e with the reaction venama. So here the oxidation reaction will happen at the ferrous, at the iron, and iron rusting will happen. So as a result, the potassium ferric cyanide will convert to blue color when iron is mixed with lesser reactive metals. So finally, we can recall an instance or an application of cathodic protection. A very good example of cathodic protection is galvanizing. So this is all about electrochemistry.